Okay, so make sure you get a Cornell note ready. The objective was on the board. I'm going to go over it right now. And you do need a fair model, so make sure you get a fair model going. However, the home plate, like I said, there are 8 exercises. Make sure you copy those, yes. So we have 1 through 5, and then we have 6 through 8. All right? So, with that said, our objective for today, I can simplify and evaluate algebraic expressions using order of operations. Let's read together. 1, 2, 3. I can simplify and evaluate algebraic expressions using order of operations. So, we already saw some of this last year. Hopefully this will be a review. But I'm going to go ahead and do the introduction the same way, so those of you that weren't with me, you actually understand what we saw last year, and hopefully you'll move on right along with us throughout the lesson a lot easier. Okay? So here we go. Everybody copy that already? Title your lesson, Simplifying Expressions. Your notes, please. All right. So expressions. An easy way that I can introduce expressions, and I've used in the past, was using the idea of going to a concert. Who remembers that one? Yeah, some of you? So check this out. So they invited us to a concert, and we go to a concert. We're front row, and I tell you guys, you know what? Some of your somebody from this class, their parents gave us concert tickets for front row. You guys want to go? Spend a whole day over there instead of here at school? They're like, no, we want to do run our mile and all our academics. So you said, yeah. So I gave you guys your parent permission slips and all that. So we're ready. So we're there. We're front row, and yeah. So Simon was kind enough to get us these tickets, right? So we get there. Lights, please. And we're front row, and we're waiting for the artist to come out, and Simon he wanted to surprise us, so here he goes. So we're like, yeah, 3 hours of Andrea Bocelli. So that's his name. He sings opera, and we're going to be there front row, and everybody's looking at Simon like, thank you, Simon. Yeah. Like, listen. Watch. Watch. So then he's no, wait. We have a special guest. And he stops, and he introduces a special guest, and bam. No. You can't see one with the other? Yeah. So that's the best way I can introduce expressions. We start with first opera, but now we are not listening to opera. What is this? It's like reggae, pop, something like that. So watch, lights please. So with math it's the same way. When we introduced the first singer, he sang opera. When math, the first thing that we learned when we did math were numerical expressions, because it was just numbers. Who remembers in kinder, right? 1, 2, 3, 4, and all that, right? So that's why those are known as numerical expressions. But as soon as it changed from opera to a different beat, it became something else. Is that correct? Same thing with expressions. As soon as you add something different to the expression, it becomes an algebraic expression. Everybody with me? So now check this out. Let me show you the difference from one to the other. Look up, please. So when we started with 1 plus 2, those were numerical expressions. Or 2 times 3, or 6 divided by 2, or 8 minus 5. All those are numerical expressions. But as soon as we change something, like the music, such as this, 1 plus 2x, 2y times 3, 6m divided by 2, 8x minus 5. Now they're no longer numerical expressions. Now they are algebraic expressions. So talk it up with your neighbor. What's the difference between a numerical expression and algebraic expression? Go.
You like opera?
So
You like opera?
I heard some of you say the algebraic have letters. Yes, and those are called what? Variables, right? So let's define what algebraic expressions are. So in your FAIR model, write algebraic expression. Algebraic expressions. What are they? Algebraic expressions are expressions that contain variables, constants, which are numbers, and operations. And let me show you some examples. X plus 3, m minus 7, 2 times y, k squared divided by 5. Those are all expressions. However, let me show you non-examples. X plus 3 equals 10, 15 equals m minus 7, 2y greater than or equal to 12, and 2 greater than or equal to k squared divided by 5. Copy that. Then on the critical attributes. So we found out that expressions don't have equal signs or inequality symbols. That's why these are non-examples. So what is a critical thing to remember? Do not have equal signs and have variables, constants, and operations. That's what makes them so special. Copy that, please. Bless you. Copy these steps. Right underneath that, steps. To simplify and evaluate algebraic expressions, number 1, substitute the given values for the variable. Number 2, use order of operations. Number 3, use the cat properties to combine like terms. And number 4, simplify. Copy that, please. Now, order of operations we already know. Is that correct?
Yeah.
But here it goes again. I'm going to recap again. You don't need to copy this, just pay attention. Order of operations look as follows. Step 1, we're looking for grouping symbols. First. Second, we look for multiplication and division. If the expression has both, then we start from left to right, whichever comes first. Does everyone understand that? Okay? So this is where some of you get confused. Let me show you the difference. Everybody look up. Whenever you have an expression that has these two, watch. And there's 8 divided by 4 times 6.
So do 6 times 4 divided by 8.
Okay. Because you guys follow the order of operations that it says multiplication and division, some of you would multiply first. However, but what does this say? From left to right, whichever comes first. So if I start from left to right, what do I do first? Division. This would be 2, and then at the end times 6, which becomes 12. Because if you do it the other way around, look what happens. 8 divided by, this is 24. Some of you might say that this is 3 and you make a mistake. Or you leave it as 1/3 and it's still a mistake. That's why it's wrong. You need to follow the order of operations. Same thing with addition and subtraction, whichever comes first from left to right. We got that? Alright, so with that said, copy this one down please. Example 1. A is 15 minus 2 times 3 plus 1. And to the right of that, copy B. And let me put that on the right. Give me a second.
Oh, you circled it wrong.
Bah.
Did I tell you?
Yeah, I did.
What? Can't you?
There it is. Okay? So let's simplify these using order of operations. So I want you to write down at the top PEMDAS, P-E, leave a space, and then write M-D, leave a space, and then A-S, so that you know that these are 3 steps. Does that make sense? Because some of you follow the order exactly how it's written. That's where you make mistakes. Okay? So here we go. Let's simplify A together. Is there
No.
grouping symbols? No. Exponents?
No.
No. Multiplication and division? Yes. So we're going from left to right, whichever comes first. There's no division here. There's multiplication. What is -2 times 3? -6. Bring everything else down. And at the end, we're doing addition and subtraction from left to right. So therefore, what is 15 minus 6?
9.
9 plus 1?
10.
10. Do the next one by yourselves. Go.
Answer. This is the right answer.
Here you go. Do we have grouping symbols? No. No. Grouping symbols?
Oh, I thought you said about exponents.
Exponents, yes. This becomes 9. Bring everything else down.
It's not the answer. Oh, it's right.
Next, do we have multiplication and division? We're going from left to right, which is here. 10 divided by 2, that's 5. Bring everything else down. Addition and subtraction, yes, from left to right. This is 26. Hands, have you got that? Okay, good. So, we did a lot of this practice towards the beginning of the year. Remember that? Kind of, sort of? Well, we did some of this, right? So any questions with order of operations? No. So now, let's move on to this next one. Everybody look up. We're going to be evaluating expressions. Evaluating expressions means when they give you an expression, pay attention please. When they give you an expression and they give you values for the variables, then you need to substitute. So watch. Look at this problem. Don't copy this, just pay attention. It says, a shop offers gift wrapping services at 3 price levels. The 3 different levels. It says, amount of money collected for wrapping gifts on a given day can be found using the expression 2b plus 4s plus 7d. Oh. Okay, my bad. 7d. So, on your paper, I want you to write example 2, and I want you to copy this expression, 2b plus 4s plus 7d. So, we're going to evaluate this one. And check this out. This is how we do this. When they give you a word problem, find out what values they're giving you. So it says, on Friday the shop wrapped 10 basic packages, which is the letter what? B. So instead of writing B here, what are we going to write? 10. I'm going to bring down the 2. Plus. Next one. It says, I'm going to circle that with green. It says 6 super packages, which is the letter S. So how many for S? 6. So we substitute that there. Plus 7, and we're going to find out how many for the last package, which is D, which is 5 deluxe. So that goes in here. And according to order of operations, here we go. We go straight to multiplication and division. So here, from left to right, 2 times 10, that's 20 plus 24 plus 35. And at the end, addition and subtraction, 20 plus 24, 44 plus 35. 79. So the question was, use the expression to find the amount of money collected for the gift wrapping on Friday. How much money was it? 79 buckaroonies. We got it?
79 pesos.
So, yes. Yeah, we just substitute and simplify. That's what evaluate expressions means. So what we just did right now, we did what? Evaluated an expression. Write that down, please. Okay? But this is not where I want to go. I want to go to the next one. Example number 3. Example 3. Check this out. Look up, please. Pens down. Now, we're going to get into expressions that have variables. But they want us to simplify the expressions. So, some of the terms that I want you to understand is that, number 1, when we add and subtract, there's some of them that are going to look the same. So here, which ones look the same? The ones that have the letter X. Do you guys see that?
Yes.
These are called like terms. Term is the part of an expression. How many parts does this one have? 1, 2, 3. How do we know it's a part of an expression? Wherever you see a plus or a minus, that's where one starts and one begins. I mean, one ends and one begins. So watch. Here we start an expression and it ends whenever you see a plus or a minus. Again, another one begins and it ends whenever you see a plus or a minus. Another one begins and it ends because there's nothing left at the end. So how many parts does this one have? 3. This is called 3 terms. Which ones are the terms that are alike? The 4 and the 3x. So check this out. This is how we combine like terms. We identify which ones are the same. These, I write the variable, and I focus just on the coefficient, this one. So what is 4 minus 3? 1, and I bring this one down, plus 2. Yes? Or you can just write x. Did everybody see what I did? So check this out. Copy these, please. So these are like terms, and this is what we call the constant. So, hold on. Coefficient. Coefficient is a number that's multiplying the variable. Focus, please. The number that's multiplying the variable. Why is it multiplying? Because this is 1 times x squared, and this is 3 times x. However, are these like terms? They look almost the same, but this is what makes them not like terms. That this one has an exponent, and this one does not. That's why you cannot combine these two. This one stays as is. Okay, so with that said, copy these, please. Example 3. Copy that, please. It says simplify the expression by combining like terms. A, and it's 72p minus 25p.
Can we copy the word?
Yes.
Can we do it?
Copy it first, and then we're going to do this one together.
Okay.
All right. How many terms does this expression have? 2. 1, 2. Do they have the same kind of terms? Yes, because both of them have the letter P, so I write P. There it is. And I focus on the coefficient. So what is 72 minus 25? 72 minus 25, 57. And we're done. Copy this next one down, please. Example Q. 4x plus 3y plus 2x plus 1. Okay, let's do it together. Do you see any like terms? Yes, the x and the x, so I write x. I focus on the coefficients. What is 4 plus 2? 6. Can we combine the y? No, that's different. So I bring down the 3y, and I bring down the plus 1. Everybody with me? The last thing that you're going to see on the home plate for tonight, look up please, is these that have distributive property. Look up. Look at this one. Let me zoom in so you guys can see it. Do you see how we can distribute this first? So if we distribute, this becomes, what is 4 times 2? 8. And what is 4 times x? 4x. And I bring down the plus and the 14x. Do we know what to do here? Can we combine like terms? Yeah, so it's x. This is 14 plus 4. That's 18 plus 8. All right, guys. Enjoy your home play for tonight, which is 8 problems that are in the first part of the video. See you guys tomorrow. If not, I'll see you during tutoring. Bye.